Pre-calculus, how's it going? Week 6 is up and running now, so you saw your to-do list and you're watching this video. We just got done talking about polar form, polar coordinates. It's going to be helpful for you if you continue down this path into some calculus. And where we're headed next is not polar form and not polar coordinates. It's going to be something completely different. But again, it's going to have its roots in calculus, okay, where we're showing this to you here at the end to help you get ready for those of you that are pushing towards calculus. So hopefully all you engineers, future engineers, and future doctors that have to take a bunch of calculus in college, this can help get you ready for that. So without further ado, this week we are going to learn about sequences. A sequence of numbers, right? An ordered list of numbers. And we've been dealing with sequences, and there's all kinds of applications for this, but the first thing that I want to talk about with sequences is just going to be a little notation stuff. So when you see certain things in the book or you see certain things on the SAT or ACT, you understand what they're talking about. So we have this ordered list of numbers. It should be pretty common, the even numbers. We have what each of them are called a term. Ooh, I should not use pink on this yellow paper. We ran out of printer paper here in Edward's household, so I'm going next up is some yellow papers, yellow pad paper I have. But all it says right here is this is an N, okay? And these are the term numbers. So this is the first term, second term, third term, fourth term. The actual term itself is the number. 2 is the first term. 4 is the second term. And we're going to use N's for these. So what can I do to the term number, these N's, to get me to the actual terms themselves? And hopefully it's not too difficult to see. You times them by 2. You take whatever term number you're on, 1, times it by 2, times it by 2, times it by 2. That's a rule we can use for the sequence. We can define this sequence as whatever term number you're on, if you times it by 2, that will give you the actual term versus term number. We've seen this before, right? We're starting at this number, then every time I move over 1, I go up by the same amount each time, move over 1, up 2, over 1, up 2. It sounds like y equals mx plus b, and you'll see that on your second video even further. But when we sequences and lines, that they have this rule that they follow, a sequence rule, an arithmetic rule, whatever the case may be. So we've seen this before. Y equals 2x is what it would be. You take your inputs, that's what the x's are. You multiply them by 2, and it gives you an output. It's no different here. You take your n values, those will be your inputs, do something to your input, and get an output. Okay, well, here's the new notation for us. We call it a sub n for a subscript. So a sub n equals 2n. Again, the entire number itself, the output would be the term. And then the input, the n value, would be the term number. Term versus term number. You want the 15th term, plug in a 15 right here. 2 times 15, it would be 30. The 15th number is 30. Okay, let's try one. It says example 1, to find the 60th term of the sequence that's defined this way. A sub n equals 2n plus 15. It's exactly as easy as you're thinking, hopefully. Don't overthink this. If I want the 60th term, I want to find a sub 60 for my n, right? I'm taking my n out and I'm replacing it with 60. I'm actually replacing both of them, all n's with 60. So a sub n, a sub 60 is 2 times 60 plus 15. Do a little arithmetic and we get 135. The 60th term of this sequence, defined this way, would be 135. Something common in this kind of section would be find the first 4 terms of the sequence. That's fine. Plug in a 1, plug in a 2, plug in a 3, plug in a 4. That would give you the first 4 terms. Okay. Piece of cake. We're off and running. There's a lot of things, a lot of stuff we can do with sequences, but there's one thing in particular that we're going to focus on, and we'll get there soon. The next thing I want to show you guys, and sometimes it trips kids up, so I'm hoping that with this online, this remote education, it will not trip you up. And it's this idea of what's called a recursive sequence. So I have the first term of my sequence, second term, third term, fourth term. I'm not breaking any barriers here. You want the next one, you take the one you're on, 1, and add 1 to it to get to this one. Add 1 to it to get to this one. Now I'm talking about the n value, not the term itself. Those can change by however they're changing, but if this is the first term, I would add 1 to this little 1 down here to get 2, and add 1 to get to 3, so on and so forth. So we get this new notation using these subscripts, and it would look like this. This is a recursive sequence. Recursive meaning we need to know something before to figure out what happens next. We need some prior information to use to find the next thing. So we can read this as to find the next term of the sequence, right? A sub n is going to be the current one. I'm currently on a sub n. To find the next one, okay, take the one you're on and add 15. So take a number, add 15. Then take a number and add 15. Then take a number and add 15. That's what this is saying to do. So it's just a little bit different with notation, this recursive idea. If I'm on the nth term, if I'm on the first one and I want to find the second one, if I want to find a sub 2, what would I have to plug in here? Well, to get a sub 2, I would need a 1 here because 1 plus 1 is 2. So if I'm plugging a 1 in for an, or for n, then I would plug a 1 over here for this n. And it becomes the first term plus 15. To find the next one, add 15, add 15. So it's just a different notation. If you focus on, if you can read these things, the math is actually really, really easy. Find the next term, take the current one, the one you're on, and add 15. Okay? Our book does it this way. I've seen it written a different way, and I'm going to show it to you guys just in case you come across this in your future math lives. But this formula, this recursive sequence, says the exact same thing. Instead of a plus 1 would be going to the future, a minus 1 means the previous one. So you want your current term, you take the one before it, and you add 15. So they say the same thing, just written two separate ways, depending on what language we're talking about. So I'll put them up there. They say the exact same thing. Okay, let's try an example with a recursive sequence. You can hit pause if you would like and try it out yourself. See how far you can get on it, if you get stuck or get them all, whatever you need to do. But hit pause now. Okay, and we're back. This example says to find the first 4 terms of the sequence that's defined recursively. So I give you this formula, and you can find the first 4 terms of the sequence. Now, a lot of you, or hopefully a lot of you that did this, paused and said, wait a second. To a recursive sequence, you need to have some kind of prior information before you can move on. I need to find the next term of the sequence. I need to find the one I'm currently on and subtract 6. But I don't have a starting point. Good call. I need to give you a starting point. There's your starting point. So now we can try it again. To find the next term of the sequence, take the one you're on and subtract 6. So I've given you the second one. To find the next one, take the one you're on and subtract 6. Okay, so to find the next one, I'm going to take the one I'm on, 1, and I'm going to subtract 6. Okay, negative 5. To find the next one, take the one I'm on, subtract 6, negative 11. So I found the second one, I found the third one, I found the fourth one. I want the first 4 terms of the sequence. I need to find a sub 1. The first term of the sequence. Well, if I'm subtracting 6 each time, then to go backwards, so if I have the second one and I want to go backwards, then we could just add 6 to it. You can also think of it too when these get a little bit more difficult, and normally if we weren't in remote education, I would hit these pretty hard because it's a good logic puzzle and it's a good way to expand your minds. But if I wanted to find the first term of the sequence, if I plugged in a 1 here, a sub 1, and I plugged in a 1 here, a sub 1, this turns into a sub 2, which we have. A sub 2 is 1. And if I put in a 1 here, that's what I would be looking for. I could solve this equation, basically, and make a new recursive relationship for going backwards. So I could just add 6 to the other side, and then it says to find the term before. You take the one after and add 6. But just use logic is fine at this point. We're just practicing some numbers, and we have recursive sequences. That's where we're at. Awesome. Okay. To wrap this up, we only have one more topic, and it's the topic that I was been excited to hit, and it's called summation notation. There's a lot going on here, so if you want to hit pause and copy this down, if you're a note taker, that's good. You should be writing stuff down. That's how you remember it better. Just watching this video and listening to my voice go on, you will not learn as much as writing it down yourself and going through it. But we have summation notation right here. This is a sigma. This is the Greek letter sigma. And the Greek letter sigma means to add a big list of numbers for us. That's what it means mathematically. Here I'm going to show you guys a little Excel sheet I was making for future for you guys. But if I highlight these cells and I leave the last one empty, and I come up here and I hit sigma, for sigma one, it means to add up all the numbers. So I just hit sigma, it would add them all up, and I would get 532 for this particular example. That's what it means for us. Sigma means to, I'm trying to find it, this one. Sigma means to add all of the terms in a sequence. So this is telling me add all the terms in the sequence. The sequence is going to be defined. They're going to give you a relationship here. They're going to give you a formula here. we have what's called the index of summation. That just means what variable we're using. Your book will use I, K. You can use whatever variable you want. This is called the lower limit of summation. It's going to be the one you start with. Start by plugging in a 1 into your formula, and then plug in a 2, then plug in a 3, then plug in a 4, until you get to the upper limit of summation, whatever n is. So you're just plugging in numbers into your formula, and it's going to kick out a sequence for you, the first term, the second term, the third term of this sequence. And then the sigma part of it will add up all those terms of the sequence. Notice the first one, that's your lower limit, whatever this number is, will always match this number. And then whatever this number is, will always match this number. Sigma notation. A branch of calculus deals with adding up a bunch of areas together, a bunch of areas, to get the area under a curve, the area of something not as easy as a rectangle. So this comes into play when we're adding up all those little areas. We're going to have some kind of sequence, and we're going to add them all up. Summation notation. We'll do one little practice one, and then we'll call it good on this first little video. You guys are going to get 2 videos today. Okay. That's what I like about this. There's no wait time. I'm just going to go, and if you need to go back, go back. Pause if you need. Okay. Find the sum. So this is telling me here's some sequence. I'm going to find all the terms of the sequence with this formula. K is my variable, index of summation. I want to start by plugging in a 1 to get the first term of the sequence, and I want to go until I get to the 4th term of the sequence. So I'm going to plug in a 1 into this, then a 2, then a 3, then a 4. I'm going to have 4 terms of the sequence, and then I'm going to add them all up. Sigma just means to add all those up. So we're just doing this by hand. I'm going to plug in a 1, 2, 3, and 4. There it is. There's me plugging in a 1. Negative 1 to the first, times 2 times 1. Negative 1 to the second, times 2 times 2. Negative 1 to the third, times 2 times 3, so on and so forth. This will get me each term of the sequence, and then I just add them all up individually, and we get 4. Piece of cake. Sigma notation. Okay, you might have to read a little bit of the chapter to fill in some thoughts and some things you're not sure about, but that's the general premise. One thing we're going to keep in mind as we move forward is being able to add these. This was easy because it was 1 to 4, but what if it was 1 to 400? What? I do not want to have to do that 400 times. So there are ways and there's techniques around this, but this is a good entry point for us. This is a good introduction. Here's a little suggested stamp. These are problems you should familiarize yourself with, things that could show up on SAT, ACT, show up in future classes, placement exams, things like that when you go to college. So take a look at them, bring any questions you have to me, and then keep working on your to-do list. I'll have a little the upload of the week coming your way. Click on it, and I hope you guys have a fantastic week. We're running out of time here. June 5th is fast approaching, so that's the last day of school, by the way. All right, see you guys.